In a noteworthy declaration that could change our situation in the universe, NASA has detailed the recognition of the first extraterrestrial signs coming from the direction of Proxima B, the nearest known exoplanet to Earth, found just over 4 light-years away in the habitable zone of its star Proxima Centauri. This disclosure has generated a rush of excitement and interest worldwide. Could this be the moment when mankind discovers that it isn't the only one in the universe? The path to this pivotal discovery began with careful observation by NASA's powerful telescopes, which have been monitoring distant stars and planets for signs of activity. Proxima B has always been a prime candidate in the search for extraterrestrial intelligence due to its Earth-like characteristics and its proximity to our solar system. The signal identified is unique and unlike anything astronomers have ever observed, marking a potential turning point in human history. The implications of such a discovery are profound. First, it confirms the long-held scientific hypothesis that life could exist on other planets under Earth-like conditions. Second, and perhaps more intriguingly, it raises the question of the nature of the civilizations that could reside there. Would they be simple microorganisms or advanced beings potentially capable of interstellar communication and travel? This signal from Proxima B isn't just random noise or a natural cosmic phenomenon. It carries a structured repetition that suggests an intelligent origin. NASA scientists, along with international teams, are now tasked with deciphering this message, trying to understand its content and the intentions behind it. The global academic community is abuzz with hypotheses and theories about the possible content of this message. An invitation, a greeting, a warning, or something completely unimaginable. News of this discovery has gone beyond the boundaries of the scientific community, igniting debates on social media, in government rooms, and around dinner tables worldwide. People are gazing up at the stars with renewed wonder, considering beings who might be doing the same on a distant world. How similar or different could their world be to our own? What might their society look like in terms of technology and culture? These possibilities seem as vast as the universe itself. This detection also opens up numerous ethical and existential questions. How should humanity respond if the signals truly come from intelligent beings trying to communicate? What protocol should we establish for interstellar diplomacy? And most importantly, how might such a discovery change our understanding of religion, life, and our very identity as humans? While excitement is growing, there is also palpable caution. Scientists at NASA and other space agencies are working tirelessly to validate these findings. It is essential to ensure that the signal is genuine and not a false positive or an error. We are on the brink of what could be the most significant discovery in human history, so the next steps must be taken with precision and responsibility. The world eagerly awaits more detailed analysis. The detection of alien signals from Proxima B not only pushes our scientific endeavors into a new era, but also unites us with a sense of cosmic curiosity and hope. We could finally be on the verge of answering one of the oldest and most profound questions. Are we alone in the universe? In April 2019, a radio transmission was detected coming from space, specifically from the Proxima Centauri region, 4.37 light-years away from us. Although it may seem like a significant distance, it is the closest star to the Sun, being 20 times farther away than the third brightest star in our sky. The signal comes from a triple star system composed of the binary pair Alpha Centauri A and B, and Alpha Centauri C, also known as Proxima Centauri. Alpha Centauri A and B, the two stellar companions, are relatively close to each other and quite similar to the Sun. Alpha Centauri A shines with a yellow light and is 1.5 times brighter than the Sun, while Alpha Centauri B is half as bright with an orange tone. Alpha Centauri A is slightly larger than our Sun, and Alpha Centauri B is slightly smaller, so our Sun fits exactly between them in size. But where did the signal between these two stars come from? The Breakthrough Listen project, dedicated to searching for extraterrestrial communication in the universe, has named the Signal Breakthrough Listen Candidate 1, BLC-1. The project, with roughly $100 million in funding, has utilized years of observation with state-of-the-art telescopes worldwide. The signal was detected by the Parkes Radio Telescope in New South Wales, Australia. This telescope was observing the region of Proxima Centauri, the closest star to our Sun. This signal almost went unnoticed among the vast volumes of data collected over years, but the scientists managed to identify it like a needle in a haystack. For the signal to be considered relevant, it must have two distinct characteristics. First, it must be narrow in a small frequency range since such radio transmissions are not made by natural processes in space. Second, the frequency must change according to the relative motion of the exoplanet concerning Earth. The scientists needed to analyze nearly 4 million individual signals captured by the telescope in Australia. After an exhaustive process of filtering and eliminating unnecessary signals, they found 5,000 distinct signals, among which one stood out. A signal that couldn't be explained after cross-checking with contemporary radio transmitters on Earth. This extraordinary signal, with a narrowband technological signature, only appeared when the telescope was pointed toward Proxima Centauri and was observed over a 30-hour period. Upon closer examination, Proxima B turned out to be very similar to Earth, with a radius 1.1 times that of Earth and a mass 1.3 times that of Earth, indicating that it is a rocky world with a similar density. However, there are significant differences. The first is the location of the two planets in their respective solar systems. Proxima B is much closer to its parent star at only 0.05 astronomical units, while Mercury is at a distance of 0.39 astronomical units from the Sun. This proximity would make Proxima B an extremely hot planet, but because Proxima Centauri is a faint red dwarf, the planet receives only 60% of the energy that Earth receives from the Sun, placing it in the habitable zone where life could exist. There are countless unknown planets scattered throughout our universe. So far, we have discovered an impressive 4,931 exoplanets and have recently added 65 new planets to our count, bringing the total to 5,000 planets. This latest batch of 65 exoplanets was added to NASA's Exoplanet Archive on March 21st of this year, marking a milestone in planetary exploration. The James Webb Space Telescope, JWST, is the most advanced telescope ever built, being 100 times more powerful than its predecessor. With its help, we will be able to unlock the secrets of the vast expanses of the universe. In the past, we have discovered a wide variety of planets, from small rocky worlds to gas giants larger than Jupiter, as well as extremely hot planets and habitable ones. Among these discoveries, a few planets stand out, particularly Kepler 1649c. It is one of those planets whose characteristics are very similar to Earth. In fact, it is the most habitable planet we have found so far and could harbor life. So far, we have identified 55 Earth-like planets, but we have not yet been able to study all of them in detail. With the rapid advancement of our technology, especially thanks to the James Webb Space Telescope, who knows what more we will be able to achieve in the future. Wouldn't it be amazing to find a planet capable of supporting life? One of the main goals of the James Webb Space Telescope during its first year of science missions is to find and study extraterrestrial worlds beyond our own solar system, focusing on how they form and the likelihood that they can contain water and organic life. Webb's research on star and planet formation allows us to connect studies of mature exoplanets to their birth conditions, as well as link our own solar system to their origins. Webb's infrared capabilities are ideal for revealing how stars and planets form for three peculiar reasons. Infrared light penetrates dust well, detects the warm signatures of young stars and planets, and indicates the presence of key chemical components such as water and organic compounds. Mid-infrared light can pass through clouds that are 100 times denser than visible light, which is especially important when observing newborn stars hidden within their natal clouds. These infrared capabilities are vital because they allow us to observe and capture the early stages of star formation when gas and dust are still contracting to give birth to young stars. However, there is more to the natal clouds of stars than that. Both young stars and giant planets begin as massive, bloated structures that gradually contract over time. As newborn stars get hotter as they age, giant planets cool, but both emit more light in the infrared spectrum than at visible wavelengths. This means that the Webb telescope will be excellent for finding new stars and planets and helping understand the physics of their formation.